Hello everyone, hope you are doing great. In this lecture, we are going to learn about advanced chemical oxidation. You learned about the oxidation in different type of water treatment processes in environmental system engineering. The example were like oxidation of iron and manganese for the removal from groundwater. So we had iron 2 and we had iron 2 that we converted that to iron 4 that was precipitate, so we removed that from water, and we converted manganese 2 to manganese 4 that was solid, so we were able to remove that from water. Another oxidation process, the conventional oxidation process in water treatment, was about chlorine, using the free chlorine residual for disinfection and inactivation of bacteria. So we are going to discuss that later in much more detail. So we have three different type of chemical oxidation. The conventional chemical oxidation that we discussed earlier, oxidation process that should be conducted at elevated temperature or even elevated pressure. So we are not going to discuss that in this lecture, and advanced oxidation processes. So I mentioned about the conventional oxidation process when we were using chlorine dioxide, or potassium permanganate for water disinfection. We were conducting the oxidation process. They didn't generate the very reactive species like hydroxyl radical, so they were slower chemical reactions compared to the advanced oxidation reactions. I'm going to discuss the advanced oxidation reactions. The advanced oxidation reactions involve the hydroxyl radicals, so they are so fast and they have several advantages compared to the conventional oxidation processes. So here for hydroxyl radical, you see the dots. Basically, this dot represents the outer electron orbital that has an unpaired electron. So basically, they are looking for other electron to get paired. So that's why they are going to attack to the chemical and destroy the chemical through oxidation process. So this is the unpaired electron. I mentioned advanced oxidation process involve using the hydroxyl radical, and is based on generation of hydroxyl radical through different type of chemical reactions. The advantage of this type of oxidation process compared to the conventional oxidation process is that they are working for wide range of organic contaminant that are present in the water. However, when we are conducting the conventional oxidation process, they are only working for a specific type of contaminant. So this is the advantage for using the advanced oxidation process. Hydroxyl radical, basically, hydroxyl radicals are very reactive and they can react readily with many organic material. This process could be conducted at the ambient temperature and atmospheric pressure, so no specific condition is required. So I mentioned hydroxyl radical has an unpaired electron, so it's going to attack to the organic contaminant and oxidize them by abstraction of a proton and forming the organic radicals. So the process could be processed and different organic radicals generated in this process. So the question, when we need to conduct the advanced oxidation process? Sometimes the water supplies, they contain some chemicals that could be very toxic. So advanced oxidation process could be applied for destruction of toxic synthetic organic material, SOM. We call them SOM. So these materials should be removed or destroyed to make the water safe for the public. So that's why we are conducting the advanced oxidation process. What type of materials considered as synthetic organic matters? Something like pesticides, herbicides. You know, sometimes the water supplies are surrounded with agricultural sites, so there are some pesticides present in those water sources. Fuel, sometimes, you know, there are some chemical spills or petrochemical spills or oil spill into the water supply, so they need to remove those organics from water because those are so toxic for the human health. And some of emerging contaminants and human drugs are considered as the toxic synthetic organic matter, and we can apply the advanced oxidation process to remove those from water. And actually, this method for water treatment has advantages over regular mass transfer processes, like when we are using activated carbon or other type of adsorbent to remove the contaminant from water. In those type of processes, we have only mass transfer. So we are going to transfer the contaminant from one phase, which is water, to another phase, which is solid. So we have the contaminant residual present on the adsorbent. So we need to do another treatment for recovery of adsorbent or something else for disposal of the contaminant. But advanced oxidation process has advantages over them because it can completely oxidize the synthetic organic matter to carbon dioxide, water, and mineral acids. So no further treatment is required in these cases. So as I mentioned, there are several advantages in applying the advanced oxidation processes. First, the contaminant can be destroyed completely. No further secondary treatment is required. We don't need to deal with the disposal of the residual. It's very effective at low concentration of the contaminant, you know, because some of the treatment practices, they're just working at higher concentration, but advanced oxidation process is working even for low concentration of contaminant. And that's the reason that they apply this for emerging contaminant or pharmaceutical compound present in the water, because they are present at very low concentration in the water. But human exposure to those very low concentration over the time could be could have some impact on the public health. And I mentioned that the advanced oxidation process, they are not that much selective like the conventional oxidation process, so a wide range of contaminant could be destroyed in this process. Advanced oxidation processes are feasible for their large-scale treatment to destroy the organic compound because they are generating the hydroxyl radicals. I mentioned hydroxyl radicals are very reactive. These processes are working at ambient temperature and atmospheric pressure, so no specific condition is required for applying these processes. And very rapidly, hydroxyl radical oxidize the organic material and destroy those, and it's not selective. We have several commercially available advanced oxidation processes. We can apply the combination of ozone and hydrogen peroxide, purging the ozone and applying the hydrogen peroxide. We can have injection of ozone and irradiation of water with UV light. We can have UV light and hydrogen peroxide, UV light and titanium dioxide, and even the combination of these technologies. In many of these processes, we are applying the hydrogen peroxide. So let's see how it's working. Before we go over the hydrogen peroxide, we need to mention that when we are applying the advanced oxidation processes, it's important that we estimate the quantity of oxidants that we require to destroy the organics. So to estimate the amount of oxidant that we require, we need to know what is our water quality. So how much organic contaminants are present in the water, what type of organic contaminants are present in the water, what is the chemistry of water, because I'm going to discuss later that the chemistry and basically the matrix, the water matrix, the type of chemicals that are present in the water, they are going to influence the efficiency of advanced oxidation process. For example, if we are in the region that has very hard water, we have lots of calcium and magnesium ion, or we are using the surface water that has lots of NOM, natural organic matter, decaying material, the efficiency of oxidation process would be completely different. So we need to know exactly what type of chemicals are present in our water to estimate the amount of oxidant and the condition. For example, if we are conducting the UV radiation, how long we should conduct the UV radiation, what should be the intensity of the UV radiation. So these are the important operational parameters. And we have the hydroxyl radicals as the main component for oxidation process. So if we have some material that interfere with that and react with that and prevent that from destruction of target contaminants, we should consider that in our operational design and operational parameters. Hydrogen peroxide, in many of those advanced oxidation processes, we are applying the hydrogen peroxide. It is a very strong oxidant. It was used before for removal of many organics and inorganics from water. But if you want to apply only hydrogen peroxide, it's not that much effective compared to the condition that we are applying hydrogen peroxide in combination with ozone or UV light. So the reaction is much faster when we combine hydrogen peroxide with another oxidant like ozone or even with UV light irradiation, because when we are conducting the UV irradiation, basically it converts hydrogen peroxide to hydroxyl radicals, which are much more stronger oxidants compared to the hydrogen peroxide.